So guys, this is my homemade CNC machine. Thought I'd show you a quick video. First of all, let me just give you some quick shots of what I got going here. Keyboard, sheet bowl, caliper, and cheap battery charger. And here's the machine. Name it 23 motors, about 100 ounce-inch Misumi aluminum extrusions. There's what I call the x-axis. Here's the Y. And a shot of the Z with the cheap Harbor Freight wood router. It's a palm router. About, I don't know, $20 on sale. Threaded rods, 1/4 right through the middle of the extrusions. This one I experimented with a piece of HDPE and a T-nut. You might be able to see the end of that T-nut right on, smashed up against the extrusion. That mark there is the WD-40 that I use to help lubricate those threaded rods. Here's a picture of the same thing on the Z, but I took a piece of aluminum and drilled a couple holes in it to help tap it. The couplers I'm using for the motors are just basic pipe clamps. Sorry. These are the basic reversible brackets to hold the extrusions together. These are bipolar steppers. Got them on sale for free on eBay. And just a little platform piece of wood here on the moving table. Really don't have a lot of range here due to the space constraints that I have. I'm using drawer slides as my linear motion mechanism. As you can see, these drawer slides have ball bearings, and maybe I can get a shot of that. Sorry about the video, it's pretty cheap. You can see the ball bearing shining in there. There's a track on this side. Of course, there's one on the other side. Right here you can see that track on top of the Y, and at the bottom. And of course, under here there's a couple. My Y is basically just bolted down, so the router stays, or the Y stays in one place, the table moves, and the Z goes up and down. I got a piece of MDF backing here. Eventually want to replace it with aluminum, but I don't really have a meal. Well, this is the meal, essentially. But I want to eventually replace the table with a piece of aluminum stock. These motor mounts with aluminum, of course, and the whole back of the Z there, and possibly even the front of the Z with an extra aluminum plate to allow mounting different types of tools in the front here. Now, I just have basic doorbell wire or 4-wire cable just pushed into the motor connectors right now, just for testing. You can see I put a header on this one, the rest of them are pushed in. And I'll show you a little bit about the electronics here. I just have a board attached to the back that I have the mounted electronics on. Sorry about the lighting, but there's my bob or breakout board. This is a treadmill motor controller scrapped from a non-working treadmill that I junked. And what I have here is a pot connected to that treadmill motor controller, which here the lines go to this electrical box, and I know those nuts need to be on the inside of the box, but that's all I could do in a pinch. And of course, plugged into that electrical box, sorry, tight squeeze here, is my router, of course, and that actually controls the speed of this non-variable speed cheap router. Just a little experiment, I was playing with some skate bearings and a chrome drawer pull. Over here I have a fan scrapped from an iMac, I think, I can't even remember, but it's a round exhaust fan. And underneath, it's really hard to see, I have my homemade motor driver board with 1, 2, 3 G-Tech DR Texas Instruments DR 8825 motor drivers, carrier boards plugged into some headers, various routing, horrible soldering job on the bottom, with the 3 caps that are needed for smoothing the power. These conduit clamps here are just to offset this temporary setup for this fan for cooling. I really need to put heat sinks on these drivers. They do get too hot to touch, even just at idle or running. But there's my 1, 2, 3 wires coming from my motor driver board to the separate motors. This power jack I stole again from the iMac is going to that motor, that treadmill motor limiter there. Piece of aluminum heatsink from the original treadmill there. And of course my bob has the USB for 5 volts and parallel port interface. It runs down, of course, to not really the crown jewel, but we'll call it that for now. This is my computer that I put together. I got it from Goodwill. It was a point of sale system that I actually talked them down to $5 for. Recycled. I have the just traditional Helios thin client. It's a thin client. I upgraded the RAM inside, and I'm using a flash drive for the OS, which I have, of course, Linux CNC built on, and just some carving and pencil tests that I've done. Had some problems with the initial setup, but I got it pretty much worked out. Little double-sided sticky tape 3M for holding down a few work pieces that I was practicing on. And the neat thing about this whole thing is it slides out. I have it on drawer slides here to give me some more work. Just some crude drawer slides that I picked up pretty cheap at the hardware store. You can see this power button from the thin client. I stripped all the plastic, non-necessary parts off of the thin client, and just have the mounted metal frame there, and quick shot of the underside. Let's see. There's the thin client, just a VIA chipset, USB breakout board, of course, a hanging computer fan because it's passively cooled, but there is a header for a fan, so I just got it kind of hanging there with some wires, and some of the heat sinks. Now, this frame I built just out of standard dimensional lumber. It's in a tight space right now. Altogether, there's some of my extra wood and other junk underneath, stuff I plan on eventually using for projects, ant killer, hard hat, and the reason why I have it all stuffed in here is because I don't have a lot of space to work with where I live. I live in a duplex, so this is my closet outside, and then just a little workspace there. And we have all our Christmas stuff stored, float for the pools, other stuff, water heater, little Hank tool rack that I made, fishing poles, random bamboo, a lot of stuff, all crammed into this little storage space. And here is Ubuntu or Linux CNC with the Axis running, and I thought I'd show you guys how this works a little bit. If I, pardon for the shakiness of the camera, this is an old phone. But if I want to jog to X, I don't know, left or right, I can go like this, just with I don't have any e-stops built in, so I'm not going to do too much right now. And this is just at I lowered the speed a little bit. I even put it on touchscreen originally from the thin client. This tape just keeps a piece of plastic over it. But like if I want to maximize the screen, I can just double click. I don't have to have a mouse, even though I have room for one. But other than that, we can change the display a little bit. And let me go ahead and zero out one more time. I'll move the Y a little bit. You can see that router moving. And then down and up for the Z. Of course, you can move 2 at one time. Alright, so they're all pretty much working just fine. I'm going to go ahead and home my Z-axis. Let's go down a little bit. I think we'll touch off. We'll go ahead and touch off. You turn this router on. Touch off right just where it taps. And let's change that increment a little bit. We'll go Z. Instead of continuous, we'll go 0.1 inches. And then we'll go minus. That's fine. We'll touch off right there. You can see that 2 flute, just standard hardware store bit. I think I got that from Harbor Freight for $2. That bit came in a 2-pack. I think I got it for clearance for like 99 cents because one bit was taken out of the pack. Anyways, we're going to go ahead and back this off. We're going to Z this up, offset my tool, and just hit end here. What that does is allows me to zero offset my tool. I'll hit OK. I'm going to pick it up a little bit. Go ahead and turn my router on. It doesn't start up right away because I have to adjust my pot. still got to work on those settings a little bit. Turn it down a little bit, and then turn it up, and you'll start to see that router come on. You can hear it too. There it goes. And now, it's running at a very low speed, probably, I don't know, just by looking at it, I don't know, 5,000 RPM, maybe less. And this is a 30,000 RPM router, so I can really pick it up super high. But for this purpose, for the demonstration here, I'm going to run it a little low, and I'm going to go ahead and hit start here, and maybe we'll get some carving done. I'll adjust the router speed if needed. We're just going to run the basic Linux CNC program. We'll see how it goes. We'll watch it as it goes. So it's carving. I'm going to go ahead and stop it. Go ahead and refresh. Pick that router back up. Go ahead and turn it down a little bit. And turn it off. So that's what we have, folks. This is not really a good, let me blow that here, good test, but as you can see, I was using a different bit for this front one, and it worked pretty well until it got to the last C, and something skipped, but still working on some of that, actually, getting it fixed. But there you have it. Modular, I say modular because I can end up changing this front out. Space constrained CNC from scratch for less than $250, because budget's tight around here. There you have it. Have a nice day, folks.